LeetCode of the day, July 8th, 2024. It's number 1823. It's called Find the Winner of the Circular Game. Let's do it real quick. It's a medium, but we got it done. Don't worry. All right, this is our fourth LeetCode of the day in a row. I'm on fire, dude. Okay, so basically, it gives you two numbers. It's how many. The first one is how many players are in the game. Okay, which is N, as we can see, and then K is like how many steps you take around this like little circle of friends, and then whoever you land on, you get rid of. Okay, so the example here is you start at number one, and then you have two steps, but you start with whichever one you're on is a step. So it would be like one, then two, and then you get rid of two, and then you're going to start from the next person in line. Okay, so that would be three here, and then you would go one, two, and then get rid of four, right? And get rid of four, and then you keep going around and around and around. Okay, and then you just return whoever's left. All right, now this sounds like a great problem on recursion. Okay, so let's do that. Okay, so let's make a function called play. All right, and it's gonna keep track of basically whatever data structure we use, and we're gonna call those players, and whatever spot we're in. Super chill, super chill. But what are players, right? So I'm gonna make it a list data structure, and the way I'm going to initialize it is a super cool way. It's called put in a for loop inside of an array, and it looks like this: for I in range. And so the players start like the first index. It starts with the player number is one, so we're gonna start it at one, and then it's going to go all the way to n plus one because it's not inclusive, right? Cool. Separate that out so you can see it. Let's just break down the recursive function. What do we do with recursive functions? We always start with base case. Okay, we do not want this to go on forever and break LeetCode. If leen of players equals 1, return players at the first index. Or we could do -1, who cares? But yeah, if there's one left, return that guy. You could also do if the second one, return it at the next giant, but we don't need to do that. That's too much work. Just make it simple. Keep it simple, silly. Okay? Now, we have the players and we know where we are. We know our spot. All right? How do we figure out where we're going to next? Well, let's make a variable called jump. Okay? Because I have a feeling we're going to be using it a few times. So let's not recalculate each time. Let's just save it. All right? And that jump is going to be equal to whatever spot we're in plus how big the jump actually, like however many steps we have to take, which is K. Okay. But if we look here at the examples in the description, we're starting one of the steps in K is whatever you're on. So really it's K minus 1. Okay. Which is a little annoying, but welcome to LeetCode. And then we're going to mod that by the length of players just in case whatever spot we're on. Like if we were on like, one at the end. I don't like these examples. But basically, if we were on like the end, and we have to keep jumping, where do we go? So yeah, that's why we use mod. But I'm sure you already know that because anybody watching this video already knows what a mod is. Okay. And then we're gonna go players dot pop, and we're gonna pop at the where we just jumped to. Cool. So simple. And then we're gonna return. Well, it's recurse. We're going to pass it to players because players is, new. And then where is our new spot? Well, we just jumped. We got rid of where we jumped to, but let's say that we're still in that spot. But we have to recalculate that because wherever we jumped to, we just popped off that spot. So we could jump to if we jumped to the end of the array and we got rid of that spot doesn't exist anymore. So we gotta mod that real quick. And we're gonna do that by length of players, right? Just to cover ourselves. All right. It's called quality assurance. That's what that is. And then let's just return it all by starting it from the beginning. We're gonna pass it players, and we're gonna start at the first index. Now let's do a little syntax check. All right, we're good, and we're gonna Submit. And it's submitting. And it's taking forever. And there we go. Time complexity. The numbers look trash, but if you're looking at the LeetCode things, sometimes the breakdown is just all over the place. Like if I resubmit it, I would like get a different score. Let's go ahead. Let's try. It was 22 and then 24. Ready? Ooh, 38 and 5. Like it's all over the place. Okay. Now, if you were like, my runtime is like 250, maybe it's you. It is you. It's you. It's you at that point. Okay. But before I wrap up, I wanted to go back to the description real quick. And I just want to point out, it has a follow-up that says, could you solve this problem in linear time with constant space? So when it asks questions like this, what it's hinting at is that you don't have to actually recurse here, or you could also do like a iteration, like a while loop, but you don't need to do any of that. Okay. You don't have to actually, you could do what's called being really good at math. Okay. Now, as a math minor myself, I know of what I'm about to tell you about, but I don't know how to do it. Okay. And this secret thing that will allow you to, as it says, solve this problem in linear time with constant space is knowing how sequences work. Okay. Now there's going to be a formula that you can plug in how many players there's going to be, and then like how many jumps you're going to have. Like there's definitely a sequential formula for this, and you could just plug it in and it would give you a constant answer, right? Because it's just doing one math equation. It doesn't have to recurse each time. And that's definitely what I'm going to be try to work on. Maybe even have a video next time I drop this and explain that, because I need to learn how to do this, because this is the second problem this week that I could have solved in a way better runtime, way better memory, way better space complexity if I had just known about sequential series, right? So yeah, keep that in mind. Like that's the next level. Start with, solving it either iteratively or recursively here like this, and then the next level is that, and we're pushing towards that. We're gonna get it. But yeah. See you guys in the next one.